Okay, I'm going to go through this review so that if you need to watch this, you can make sure you understand everything. I haven't done this ahead of time, so just know there definitely could be some mistakes as I go. Hopefully I'll catch them, but you know, that's what's hard about math. We all make mistakes. All right, number one is a method for finding max or minimum values of a function over a given constraint. That's linear programming, right? So that's this one. So this one is linear programming. Number two, what is an algebraic method for solving systems that eliminates? Well, that would be the elimination method. I'm abbreviating here a bit. A system of equations is blank if it has at least one solution. At least one solution means it's consistent. To what means to seek the best price or profit using linear programming. To optimize. Optimize means you want to find the best, the least cost, or the maximum profit. Number five, a feasible region that is open and can go on forever is unbounded. Unbounded, that would be, where's unbounded? Oh, alphabetical. The what is the point at which the income equals the cost? That's the break-even point. A system of equations is what if it has an infinite number of solutions? It's dependent. We say consistent and dependent. What is two or more equations with the same variables? That's just a system of equations, right? Equations. So this is just a system of equations. A system of equations is what if it has no solutions? That's inconsistent. We're going to abbreviate that. And to solve a system of equations by the blank, you solve for one and substitute it back in. That's easy to know that it's the substitution method, right? Substitution. All right? Doesn't mean that these other words aren't important, but that's all that was on here. And then it says solve by graphing. I'm definitely going to ask you to graph on these problems, at least one problem. If you solve it by substitution or elimination, just make sure I can see the graph too, because I feel like that we should be able to graph these. So if I was going to do number 11 here, the first thing that you would have to do is you would have to put it in slope-intercept form. So I would divide by 4. Then I would get y equals negative 3/4 x plus 2. So that would be up 3 and back 4, or down 3 and over 4. And if I did the other one in slope-intercept form, that would be negative x minus 6. So if I divide by negative 3, I get 1/3 x plus 2. So then I go up 1 over 3. And then very nicely, they intersect at the y-intercept. But if I ask you to graph it, I want to see the graph. And then also remember that in the equation, the system, I want the solution, which is that x is 0 and y is 2. Okay, I'm going to erase this so that I can just making that noise. All right, let's hope all is well with my microphone. Number 13, not much to put that in slope-intercept form. I'm just going to add 3x, so that would be 3x plus 13. And so 13 is off my graph, right? So if I wanted to pick another point, I could, what if I pick 2? That's going to be a big number. What if I pick negative 2 for x? Then y would equal negative 6 plus 13, which would be 7. So that means the point negative 2, 1, 2, 3, 4, 5, 6, 7 is on my graph. And then the slope would be up 3 over 1, which makes sense that up 3 over 1 would be off my graph. Down 3, back 1. I don't know where these are going to cross, so I'm just making a lot of dots. And then 1/3 x plus 5, 1, 2, 3, 4, 5. If I go down, up 1 over 3 would be going this way. But if I go down 1 and back 3, it goes like this. And again, the point of intersection would be where they cross, which is right here. So you just need to tell me that's -3, 1, 2, 3, 4. Okay? And then I gave you a story problem just because you're going to happening with my smartboard. It just like went black. Okay, let's hope that things are going well here. I'm going to make you do a couple story problems. So remember, define your variable. So Andre and Paul each mow lawns. Andre charges $30 service fee and $10 per hour. Paul charges $10 service fee and $15 per hour. How many hours will Andre and Paul charge the same amount? So I'm going to say C equals the cost and H equals the hour. So Andre costs $30 plus $10 per hour, and Paul charges $10 plus $15 per hour. And this would be a great one that I would do substitution on. I'm going to take this and just move it up. Well, that's weird that the axis didn't go with it, right? Let's just move this out of the way. Goodness gracious, what's happening with my life? So substitution, I could just set these, since they both equal the cost, I want to know when do they equal each other, right? So I can just set them equal to each other. So I can subtract 10 over here, and I can subtract 10h over here, and I get that 20 equals 5h, so h equals 4. So how many hours will Andre and Paul charge the same amount? After 4 hours of mowing, it would be the same price. Okay? This one says by substitution or elimination, your choice, okay? I'm going to do one each way just to remind you. 16, I would definitely do elimination, but you could do substitution here. If I said x equals 6 minus y, because that's just moving the y over, then in the bottom equation, I could take 3 times 6 minus y minus 2y equals -2. So that would be 18 minus 3y minus 2y equals -2. And I'm going to go ahead and subtract 18 to get -5y equals -20. And I get that y equals 4. Plug that back into the top, and x equals 6 minus 4, so x equals 2. And you can totally leave your answers like this, but you can also write them as ordered pairs. And you can check that they work in the problems there. 6 minus 4 equals -2. 19 would not be a great one to do substitution, in my opinion. I'm going to do elimination, and I'm going to make my y's the same, okay? So I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by -3. So I get 6y minus 10x equals 0. And on the bottom, I get -6y plus 12x equals 6. Again, I like to multiply so that they're different signs so that I can just add, because these cancel. This would be 2x equals 6 and x equals 3. And then I have to plug that back into one of these equations. It doesn't matter where. I'm just going to go to the very top one, and that would become 5 times 3 is 15. So 3y equals 15, y equals 5. And then check that that works, right? 10 minus 12 is -2, and 15 minus 15 is 0. Graphing inequalities. So inequalities, you can still use substitution to find the point where they cross, but, oh, that's not what I want to have happen. What is happening with my life? I want to do this. Okay. My computer is going crazy. So these are already in slope-intercept form, but if they're not, you would want to do that first. Pay attention whether it's dotted or solid. So this one has a y-intercept of -3 up to over 1, up to over 1. This one's dotted. Y is greater than or equal to 4. Lots of people are still messing up y and x numbers, right? Y is a horizontal line with 0 slope. That one should be solid. Everything less than the slanted line would be below the line. Everything greater than this one, so everything greater than the solid line that's less than this one should be this corner right here. If I do number 24, also already in slope-intercept form, but it has a y-intercept of 1 and a slope of 1. And it would be a dotted line roughly like this. Remember, if you forget to do it dotted, you can just write the word dotted on the line so I know. X is a vertical line, so -2 would be like this. And everything greater than this line would be above this line, less than the vertical line would be behind it. So everything that's above and behind would be over here. Three equations and three variables, okay? So number 28 doesn't have all three, but maybe you're going to have one like that. But number 28, it is really nice that these both have just B and C. So if I was going to do this, I would start right here by getting my B's to cancel, and I would multiply this top equation by -3. So I would have -3B plus 9C equals -30. And on the bottom, I would have 3B minus 8C equals 24. And again, I've made it so they're different signs, so I can just add. So that just gives me C equals -6. And if I know B, then if I know C, then I can just plug back into one of those equations that has B and C in it. -6 times 3 is 18. So if I subtract 18, I get B equals -8. Then I have to go to an equation with A in it, and A minus 4B, so 4 times -8, plus C, which is -6, equals 3. So that would be plus 32 minus 6, 26. So that would be A plus 26 equals 3. So I get that A equals -23. Is that true? I'm going to check my answer here, kids, by just plugging it in. So if I plug it in, the bottom one, -24 plus 48 is 24, so that works. And then -8 plus 18 is 10. And then -23 plus 32 minus 6 is 3. So all those answers work. If you write it as an ordered triple, that would be -23, -8, -6. Number 30 is a story problem, and it says, Dustin, Lewis, and Marcy went to an amusement park. They purchased snacks from the same vendor. Their snacks and how much they paid are listed in the table. How much did each snack cost? So right here we have our variables, right? H for hot dogs, P for popcorn, and S for soda. So Dustin has 1 hot dog plus 2 popcorns plus 3 sodas equals $15.25. Lewis has 2 hot dogs plus 0 popcorn plus 3 sodas equals $14. And 1 hot dog plus 2 popcorn plus 1 soda equals $10.25. So again, I'm looking for the equations. And then it said, how much does each snack cost? Well, this one only has H and S in it, so it's kind of up to you. But I say we should do these top 2 equations, and if I subtract them, H plus 2P plus 3S equals $15.25, and H plus 2P plus S equals $10.25. If I subtract these, and again, I think you should subtract all the way through. Look at this. The H cancels out, the P's cancel out, and I get 2S equals $5. Divide by 2. Since we're talking about money here, I'm going to say a soda costs $2.50. So right away, I know what that is. So we could go back to this equation now and say 2H plus 3 times 250 equals $14. And what would that be? $7.50. So I'm going to subtract 750. And 14 minus 7 would be 7, so minus 50 more cents would be 650. Divide by 2, and I get that a hot dog costs $3.25. And now, to go back and find popcorn, I have to use one of the original equations that has a I'm really stressed that this isn't recording my voice at all. So if I go back to the first one, hot dog plus 2p plus 3s equals 1525. So, oh wait, I guess I could have gone back to this one. Oh well. No, that was s. So I have to do this one. So a hot dog is 325. I'm trying to solve for p. And a soda was 250. So you could totally do this on your calculator, but 250 times 3 we already said was 750, right? So 750 and 325 would be 1075. So I'm going to subtract 1075 from both sides. 450. So divide by 2, and a popcorn equals $2.25. A little harder to guess and check when you're talking about dollars and cents, but totally doable. Okay, so remember to write your equations, and hopefully this helps as you're doing your review. So also we have the linear programming, okay, and so it says graph the system of inequalities, name the coordinates of the feasible region, and then find the maximum and the minimum of this problem. So again, I need a graph. And the first thing I'm going to do is I'm going to graph my my equations here. So this, they just put it all together, but that's just saying y is greater than -3 and y is less than or equal to 5. So they're just, -3 would be like this, right? And y is 5 would be up here. So it's just restricting you between those values. Like if you shaded in between here, it would just be here. But also, I got to put this in slope-intercept form. So that would be -4x plus 5. So 1, 2, 3, 4, 5. And then if I went down 4 over 1, 1, 2, 3, 4 over 1. Notice that they're intersecting my lines already, so that's a good thing. And then this one would just be positive 2x plus 5. So also it starts here at 5, but now I'm going to go up 2 over 1 or down to, oh no, that's the wrong way, up 2 over 1 or down 2 back 1, down 2 back 1, down 2 back 1, down 2 back 1. And I want to make sure that that is in that region, but I think that it is. It's everything less than, oh, I don't think it is. Everything less than both lines, right? And they both have, oh goodness. Okay, look, I did so good through this whole video. And then I messed up the last one, didn't I? This is a negative slope. No wonder I was struggling so much. I made it have a positive slope. But I caught my mistake because it didn't match. Okay. So this one's right with a slope of 2. But this one's wrong, right? Slope of -4, if I go down 4, it should be over 1. 1, 2, 3, 4, over 1, right? That should be like that. You always want to check your lines and make sure they make sense. So everything less than that, that's less than this, would definitely be this region. So this is kind of what math is, like figuring out where you mess up, using what you know it should look like to figure out what went wrong, right? That's what I just did there. So graph the system, name the coordinates of the vertices. So this is the point 0, 5. This is the point 2, -3. And this is the point 1, 2, 3, 4, -4, -3. And then the difference between what we did in 3.3, which is just tell me the coordinates, is it gives you a function to maximize or minimize. So it says find the maximum and the minimum. So I'm going to plug in each of these points. And see what I get. So if I plug in 0 for x there, I'm just going to get negative 3 times 15 is negative 15. On this one, I'm going to get negative 16 plus 9, which is negative 7. And on this one, I'm going to get 8 plus 9, which is 17, which means my maximum is 17, and my minimum is negative 15. Okay?